Good morning, all of you. Welcome to Sri Jainza Rank Zone. In the previous session, we have completed about pH problems. Now, in this session, we are going to discuss another important topic in this chapter, that is buffer solutions. Buffer solutions are very tough to substitute the numericals, but if you understand, it is very easy. So please listen carefully all the topics. Now, in this session, we are going to discuss what are buffer solutions. What are buffer solutions? Let us start now. So, what are buffer solutions? Buffer solutions are those which resists any change, any significant change in pH of solution on addition of small amounts of strong acid or strong base or on dilution. So, what are buffer solutions? In simple words, I'll tell you. So, a solution which resists change in its pH value on long standing. A solution here I'm writing, just please note it down in your own language, you can write easily. A solution which resists the change in its pH value, the change in its pH value, the change in its pH value on long standing or on dilution, simply I'll write on dilution. On dilution or on addition of small quantity of acid or base, addition of small quantity of acid or base is called as buffer solutions, is known as a buffer solution. So in simple language, I have written for you to understand better. So consider one solution, either it can be acidic solution or basic solution. So consider one solution. For that solution, if you are going to add small amount of quantity of acid or base on this by dilution, it tries to change its pH value. The solution will resist the change in its pH value. So that type of solutions are called as buffer solutions. So buffers are solutions which resist any change, which resists any significant change in pH of solution on addition of small amounts of strong acid or strong base on dilution. So these are called buffer solutions. So basically we have two types of buffer solution. One is acidic buffer and there is basic buffer. So on the next slide, we are going to discuss. First of all, what is buffer solution? You can write either this definition or even what I have written on the slide. That also you can write. A solution which resists the change in its pH value on dilution or an addition of small amount quantity of acid or base is known as a buffer solution. So buffer solutions are very, very important. In the examination, they'll ask what is acidic buffer solution, what is basic buffer solution. So many types of questions you are going to get. So that's why please listen carefully. So the solutions whose pH does not change by the addition of small amount of small quantity of acid or base is called a buffer solution. Simple words, a solution whose pH does not change even by the addition of small amount of acid or base are called as buffer solutions. Continuation. So as I told you, there are two types of buffer solutions. One is acidic buffer and another is basic buffer, and another is simple buffers. So mixed buffers, they are nothing but acidic buffers and basic buffers and simple buffers. Now let us see now. Acidic buffer is a mixture of weak acid. Very important. This combination they'll ask which of the following is acidic buffer solution, which of the following is basic buffer solution. So acidic buffer is a mixture of weak acid and the salt of the weak acid with a strong base. Very, very important, strong base. Example, acetic acid and sodium acetate. Here, acetic acid is CH3COH and sodium acetate is CH3CON. And in this common will be acetate ions. Acetate ions is a common. So this is called acidic buffer. Salt of here, this sodium acetate is salt. How it is obtained from sodium acetate? We can say salt of weak acid with strong base. How this sodium acetate is formed? When acetic acid is combined with sodium hydroxide, acetic acid is combined with sodium hydroxide. Sodium hydroxide is a strong base and acetic acid is a weak acid. So weak acid and strong base combination, it gives you salt. What is the salt name? CH3COONA, that is sodium acetate. So this salt is nothing but consisting of combination of weak acid plus strong base. Weak acid plus strong base. So that's why a buffer solution, acidic buffer, is a mixture of weak acid and the salt of the weak acid with the strong base. This is called acidic buffer. So example, acetic acid and sodium acetate and hydrogen cyanide and potassium cyanide, because this potassium cyanide is obtained from potassium hydroxide. When if you react, hydrogen cyanide is a weak acid. When combined strong base like potassium hydroxide, it forms potassium cyanide mainly. Potassium cyanide and remaining it forms water. So potassium cyanide is a salt. So potassium cyanide is what? Salt obtained by the means of weak acid plus strong base. Sodium acetate is a salt obtained by the means of weak acid and strong base. Potassium cyanide is a salt obtained by the means of weak acid and strong base. So that's why the mixture of these two solutions and the mixture of these two solutions are called as acidic buffers. So how we get salt of weak acid and strong base? I hope you understood. So to get salt of weak acid and strong base, we have to react weak acid and strong base. When a weak acid combines with strong base, it forms salt of weak acid and strong base. Again, I'll tell you, when a weak acid combines with strong base, when a weak acid combines with strong base, it forms salt obtained by the means of weak acid and strong base. So this is the salt. Here, sodium acetate is a salt and potassium cyanide is a salt. So this is called acidic buffer solution. This is called what? Acidic buffer solution. It's very, very important. Please note down. Next continuation. What are basic buffer solutions? Basic buffer is a mixture of weak base. Here, just like same weak acid in the case in here, weak base and the salt of weak base with a strong acid. Example, ammonium hydroxide and ammonium chloride. How ammonium chloride is formed? Let us see now. Ammonium hydroxide is a weak base. When it combines with this is weak base. When it combines with HCl, that is strong acid, it forms HCl is a strong acid, as you already know. So again, I'm writing here since S is not visible clearly. It forms what? Ammonium chloride, NH4Cl plus water, plus water. So this is called salt by the means of weak base plus strong acid. Weak base plus strong acid. So in this way, you'll get salt obtained by the means of weak base and strong acid. So this is called basic buffer solution. It is a mixture of weak base and the salt of weak base with strong acid. Same salt you have to take. Here, the common ion should be there. NH4 plus and NH4 plus is common. In the previous case, acetate ions are common. So that's why common ion should be there. And this is called basic buffer solution. What is a basic buffer solution? It is a solution which consisting of a mixture of weak base and it's salt with strong acid. And it's a salt with strong acid, or you can say, and the salt of weak base with strong acid. Same, both are same. So this is called basic buffer solution. Definition wise, they are very, very easy. So this is about basic buffer solution and acidic buffer solution. Let us see next. Buffer equation, Henderson equation, very, very important. So how to calculate pH for acidic buffer solution and pH for basic buffer solution. So pH for acidic buffer solution, pKa, that is negative logarithm of Ka plus log of concentration of salt by concentration of acid, where pK is nothing but dissociation constant of acid and concentration of salt by concentration of acid. That is, so let us say for example, buffer solution CH3COOH plus CH3COONA. What is this called? This is called acidic buffer solution. Now for this, how to calculate pH? pH is equal to pKa, 1 / 2 × 10⁻⁴ - 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10⁻⁴ / 2 × 10 that is pKa of acetic acid, because it is acid, plus log of concentration of salt. What is the salt here? CH3COONA by concentration of acid, that is acetic acid, that is CH3COOH. CH3COOH. So in this way, we will calculate acidic buffer solution pH. Similarly, for basic buffer, so what is the basic buffer example? We have ammonium hydroxide plus ammonium chloride. I'm doing substitution part so that it is easy for you to understand in the examination. So for numerical, because from this you may expect a numerical or theoretical question. What type of questions you are going to get from this topic, I'll explain you once we finish up this topic. So ammonium hydroxide plus ammonium chloride. So here this is called what? Basic buffer solution. It is what? Basic buffer solution. It is an example of basic buffer solution. To find, first we have to find POH. POH is equal to PKB. That is PKB of what is the base here? Ammonium hydroxide, weak base, plus log of concentration of salt. What is the salt here? Ammonium chloride is a salt by weak base, that is concentration of base. What is the base? Concentration of base here, it is called concentration of base is equal to ammonium hydroxide. So in this way you have to substitute this. That's why I have shown you with an example to substitute the values, because you should know which is salt, which is base also. A salt is found by a combination of acid and base. It can be the combination of strong acid, strong base, weak acid and weak base. And in this case here, it is a combination of weak acid and strong base, or strong acid and weak base. So in case of acidic buffer, the salt is a combination made up of weak acid plus strong base. And the salt is found by a combination of, here in this case basic buffer, weak base plus strong acid, that is NH4Cl. So in this way you have to substitute. Please note it down in your classwork. The substitution part is important. You should know which is salt, which is base. Otherwise you cannot substitute the formula easily. And this is the pH of buffer solution is calculated by using Henderson equation. So what is Henderson equation? For acidic buffer, the pH value is equal to pKa plus log of concentration of salt by concentration of acid. And for basic buffer, first we will calculate POH, that is pKb plus log of concentration of salt by base. And then we can calculate pH is equal to 14 minus POH. So how to calculate pH of basic buffer solution? After calculating POH, we have to calculate pH is equal to 14 minus POH. So 2 steps in basic buffer and 1 straight step in acidic buffer solution. So first we have to identify whether they are given basic buffer solution or acidic buffer solution. If they are given basic buffer solution, we have to take first POH. If they are given acidic buffer solution, directly we can find out pH. And one more important point, how to find K. pKa is equal to pKa is equal to minus log Ka, because sometimes they'll give Ka values also to find pKa. Similarly, pKb is equal to minus log Kb, minus log Kb. So in this way, you'll find pKa and pKb. Very, very important. So once you find the answer, you'll get the answer easily. So this is the formula for finding pH of acidic buffer. What is the formula for finding pH of acidic buffer using Henderson equation? pH of acidic buffer is equal to pKa, that is dissociation constant with negative logarithm of dissociation constant of acid or ionization constant of acid plus log of concentration of salt by concentration of acid. And for basic buffer, POH is equal to pKb plus log of concentration of salt by concentration of base. In this way, you have to calculate. After calculating for basic buffer, first we'll calculate POH, then we'll calculate pH, that is 14 minus POH, because already we know pH plus POH is always equal to 14. pH plus POH is always equal to 14. So that's why we'll calculate like this. So this is clear. Next continuation. You have to copy down what we have written separately. Then only can understand. Now we have started numerical already. So this is about buffer solution. More points about buffer solution I'll write to at the end of the lecture. So first we'll see example 1. Calculate the pH of a solution which is 0.1 molarity in HA and 0.5 molarity in sodium A. That is, A is nothing but acid. So it is HA is a weak acid and this is the salt. Here what is, as first you have to identify which is acid, which is salt. This is acid because hydrogen acid. This is weak acid and this is salt. Salt found by means of weak acid plus strong base. And the common ion in this is A minus and A minus. So easily you can understand. So calculate the pH of solution, which is 0.1 molarity in HA and 0.5 molarity is NaA. And Ka for HA is also given 1.8 10 to the power of minus 6. So Ka for HA is given is equal to how much it is? Equal to 1.8 10 to the power of minus 6. Now we are going to start for this type of question. So straight away we have to substitute pH value. So let us take now. Okay. So this I'll write it in a separate page because it's very lengthy calculation. So I'll do it here. So please try to understand. Solution I'm doing for example 1. Solution. What is the formula for finding, since it is an acidic buffer solution, because it is a combination of weak acid and salt obtained by means of weak acid and strong base. So for acidic buffers, I'll write in detail step by so that easily can understand. For acidic buffer, pH is equal to pKa plus log of concentration of salt by concentration of acid. And now what is given? Let us see now. They are given Ka is equal to given. What is given? What are the given conditions now here in this the numerical? So numerical, I'm previous numerical. You have to check now. So you can see the numerical here itself. So Ka is equal to 1.8 in 10 to the power of minus 5. I think it is minus 5. Yes. Implies Pk is equal to minus log of 1.8 in 10 to the power of minus 5 is equal to 5 minus log 1.8. And log 1.8 value is equal to 0.253. So 5 minus 0.2553. So it is coming around 5 minus 0.2553. 5 minus 0.2553 is equal to 4.74, approximately 4.7447. This is pK value. Now concentration of salt. Concentration of salt is given how much? Concentration of salt is equal to, let us check now. I'll just show in previous slide. Is 0.1 and concentration of acid is also equal to 0.1. So by this we can write pH is equal to let us wait for example now. I'm just trying to move the slide. That's why it's very difficult to do problems on this because the space is less, but still we'll do it now. Yes. So it is 0.1 molarity CH3OH and 100 ml of, they have given 100 ml of each, and 100 ml of each is also given. So this is example 2. Let us see example 1. Calculate the pH of solution 0.1 molarity and 0.5 molarity. So now we are going to discuss 0.1 molarity and 0.5 molarity. So concentration of acid is 0.1. So let us see again. acid is 0.1 and base is 0.5. So this is 0.5, concentration of salt is 0.5 and acid is 0. So pH is equal to 4.74, that is pK value, plus log of concentration of salt, that is 0.5, by concentration of acid, that is 0.1. So it is equal to how much? It is how many times it will go? It will go for 5 times. So log 5 value is 0.7. So 4.74 plus 0.5 divided by 0.1. So it is equal to 5. 0.5 divided by 0.1 is equal to 5. So log 5 value is 0.7 approximately. That is 4.74 plus, I'll write it clearly, 4.74 plus 0.7 approximately 4.74 plus 0.7 which is equal to 4.74 plus 0.7 is equal to 5.44, and the answer they are given 6.44. It is wrong. Answer is 5.44. Let us check again. So 5 minus this is equal to 4.7, because 5 minus 5 log 1.8, that is 5 minus log 1.8. Log 1.8 value is 0.2553. So this is 100% pK is equal to 4.74. So since pK of acetic acid is 4.74, 4.74 plus log of concentration of salt by concentration of acid. Since concentration of salt is given 0.5, concentration of acid is equal to 0.1. So 4.74 plus log 5. So log 5 value is equal to 0.7. Since log 5 is equal to 0.6989, that is equal to log 5 is equal to approximately I have written 0.7. So answer is 5.54. It is not 6.54, 6.44. Please correct it. Please correct it. So in this way you have to do the numerical. Please check it out. So let us see again. So in this way you have to do. So I'm clearing this. So please note it down. For acidic buffer solution, pH is equal to pK plus log of concentration of salt by concentration of acid. So K is equal to 1.8 10 to the power minus 5. pK is equal to minus log of 1.8 10 to the power minus 5. It is equal to 4.74. And concentration of salt is given already 0.5. And concentration of acid is equal to 0.1. You can see the previous problem also. Whenever the problem is given to you, please note down the problem. Then you see the solution. It will be easy for you to understand. Send. So pH is equal to 4.74 plus log 5. Log 5 value is 0.7. So that is 0.6989 exactly. So we can round it up to 0.7. So 4.74 plus 0.7, it is equal to 5.54. So I hope it is clear. Please note down the solution also. Next question. Example 2. So example 1, it is clear. So it is given 6.44. It is wrong. It is answer is 5.44, because after perfect this is 10 to the power minus 6 is given, so it could be 6.64, 6.44 only. I have taken it in the case of 1.8 10 to the power minus 6 we have to take, but I have taken 10 to the power minus 5. So please, anyway, the solution is same. So please take it clearly. Next, I'll write it here clearly, the question again, so that you can easily understand the answer. Calculate the pH of a solution obtained by mixing. This is model number 2. Is what? Model number 2. By mixing 100 ml of 0.1 molarity acetic acid and 100 ml of 0.05 molarity sodium hydroxide solution, and Kf for acetic acid is 1.8 10 to the power minus 5. Kf for acetic acid is 1.8 10 to the power minus 5. It is approximately equal to 4.74. Straight away you can write easily. They are asking us to find pH of a solution obtained by mixing 100 ml of 0.5. When they are given volume and molarity, we have to substitute the formula. I'll write the formula here. Please note it down. pH is equal to pKa plus log of concentration of salt by concentration of acid. And salt is not given. So first you have to substitute the formula for finding salt. So for finding salt, concentration of salt is equal to M1 V1 minus M2 V2 by V1 plus V2. M1 V1 minus M2 V2 by V1 plus V2, because to find the concentration of salt. And salt is obtained by the combination of these two only. So in this, which is M1, 0.1 into 100 is 10 and 0.05 into 100 is 5. So we can say 0.1 into 100, that is in the case of acid, minus 0.05 into 100, that is in the case of base, by 200, 100 plus 100. So it is equal to 0.1 into 100 is 10, 0.05 into 100 is 5, 10 minus 5 by 200 is equal to 5 by 200, 5 by 200, which is equal to 0.025, 0.025. So this is the concentration of salt. Now, therefore, pH is equal to, so you can find pH because pK value, Ka value is given, so you can find out pK value. So we can do like this. So pK is equal to, so pH is equal to, since in the previous numerical we have done pK value is equal to 1.8 10 to the power minus 5, we can write for this the value Ka is equal to, Ka for acetic acid is given, so pH is equal to, finally I'll do up now here, that's what I'm here. We are unable to find the space, but still I'll try to do it here, because in the next page if we go, you'll not understand clearly, so that's why I'm doing it here. Okay, anyway, I'll do it in the next page better. Let us see what is given. 100 ml of 0.1 molarity acetic acid, 100 ml of 0.05 molarity NaOH solution. Now let us start the solution for this answer. Second page I'll do it. Answer is 4.74. Let us see solution for this. Solution. What they are given? Given volume of acetic acid is equal to 100 ml and volume of sodium hydroxide is also equal to 100 ml. And next, molarity is equal to acetic acid. Molarity of acetic acid is equal to, molarity of acetic acid is equal to 0.1 molarity, and molarity of sodium hydroxide is equal to 0.05 molarity, and Ka of acetic acid is equal to 1.8 in 10 to the power minus 5. These are the questions given. So for this, first we have to take pK is equal to minus log of 1.8 in 10 to the power minus 5 is equal to minus log, that is 5 minus log 1.8, because 10 to the power minus 5 minus becomes plus. So 5 minus log 1.8, which is equal to 4.74, because 1.8 value is 0.2553. So 0.26 approximately. So pK value is equal to 0.474. And now pH is equal to, sorry. Next we have to take, since in this numerical, what is given here, very, very important. So for finding pK and pH for a buffer solution, we have to take concentration of salt. So concentration of salt is equal to M1V1 minus M2V2 by V1 plus V2, because salt concentration is not given. By combining these two only, we will be getting salt, that is sodium acetate. So definitely you have to do like this. So M1 V1 is 100 ml into V1 is 0.1. So that is equal to 100 into 0.1 minus 100 into 0.05. So it is equal to divided by 200. So divided by 200. Please try to understand. That is equal to 100 into 0.1 is 10 minus 5 by 200, which is equal to 0.025. Now pH is equal, therefore pH is equal to 4.74 plus log of concentration of salt. Salt is how much? 0.025 by concentration of acid, that is 0.1. Acid concentration you have to take like that only. So it is equal to 4.74 plus 0.025 by 0.1 is how much? 0.25. So log 0.25, log 0.25 is equal to, since log 0.25 is equal to minus 0.602, so it is 4.74 and it is less than 1. So answer is 4.74 minus log 0 plus log 0.25 value is minus value. So we have to neglect it. So it is answer is 4.74 because log 1 is 0. So it should be less than 0. So should not consider this. So only 4.74 is the answer. In this way, you have to calculate. So please try to understand. They are given volume of acetic acid. When they are given volume of acid and base, we have to calculate concentration of salt by using the formula M1V1 minus M2V2 by V1 plus V2 because acid and base, milliequivalents of acid minus milliequivalents of base by V1 plus V2. So in this way, you can calculate. I hope it is clear. Continuation now. So 10 minus 5 by 200 is equal to 0.025. So this is concentration of salt. After finding concentration of salt, substitute the value in Henderson equation, that is pH is equal to pKa plus log of concentration of salt by concentration of acid. So concentration of salt is 0.025 by acid is 0.1. And since it is less than log 1 is 0 already we know. So we should neglect this value. So 4.74 is the answer. Approximately 4.74 is the answer. I hope it is clear. So please copy down this solution. As the solution is very lengthy, that's why I have done it in the next page. So please try to understand it. Next continuation. So for continuation, you have to clear the drawings. Next, example 3. How much volume of 0.2 molarity solution of acetic acid should be added? This is more typical problem, very, very important model for advanced level. How much volume of 0.2 molarity solution of acetic acid should be added to 100 ml of 0.2 molarity solution of sodium acetate to prepare pH of 5. They have given everything except the volume should be added to acetic acid. Volume of acid is not given. So in this case, what is the formula you are going to apply? I'll just write the formula now. Please note down. pH is equal to pKa plus log of molarity of salt into volume of salt by molarity of acid into volume of acid. So they are given sodium acetate molarity and volume. Molarity of salt into volume of salt is given, but molarity of acid is given, but volume of acid is not given. So straight away we can use 5 is equal to, because pH is given as 5, 5 is equal to pK, that is 4.74 is already given, plus log of molarity of salt. What is the molarity of salt? Here the salt is sodium acetate. So 0.2 into volume of salt, it is 100 ml by volume of acid we have to find into molarity of acid 0.2 into x, and from this we have to find out x. So this we can take it as 5 minus, if you bring this, so log of 0.2 gets cancelled, 100 by x. 100 by x means it is equal to log 100 is 2 log 10, that is 2. So I'll do it here, simple calculation. So 5 minus 4.74 is equal to what I have done. 5.4.74 I have bring this side is equal to log 100, log of 100 by x, log of 100 by x. So continuation with this, I'll do it in the next page. So 5 minus 4.74 is equal to log 100 by x. I'll do it clear. So next page, what is the given count? 5 minus 4.74 is equal to log of 100 by x. Since this is in the form of log a by b, so log a by b is equal to log a by b is equal to, since log a by b is equal to log a minus log b, log a minus log b. So we can write, so 5 minus 4.74 is equal to 0.26 is equal to log 100 minus log x. So log 100 is 10 square, that is 2 log 10. So log 100 value is 2. So 2 minus log x. So by 0.26 is equal to 2 minus log x implies 0.26 minus 2 is equal to minus log x. So it is equal to 1.74. 1.74 with minus sign is equal to minus log x. So minus minus gets cancelled here. So log x is equal to, by as you can say, log x is equal to 1.74. So log of which value becomes 1.74? That we have to check. Log of 1.74 is equal to log 55 value. Since log 55 value is equal to 1.74 implies x is equal to 55 ml. So how much ml we should add? 55 ml. Very, very important numerical and lengthy process. So please note it down stepwise. So 5 minus 4.74 is equal to log 100 by x. So 0.26 is equal to log 100 minus log x. That is 0.26 equal to 2 minus log x. Like this you have to get. Since log of a is equal to log of a by b is equal to log a minus log b. So I have to do the step like this. So answer is 55 ml. So the previous question answer is 55 ml. So please copy down this calculation part. Very, very important model. How much volume you should add means we have to take into consideration this formula. Next question. Next question. Once we'll see previous question. Okay. Next question now. Example 4. Calculate the pH of a solution obtained by mixing 100 ml of 0.1 molarity HCl with 100 ml of 0.2 molarity NH3. Kb for NH3 is given. They have given Kb value. Here also they have not given salt. They have given only ammonia. This is acid and this is base. So when they are given acid and base, first of all, we need to calculate. We need to calculate what? Concentration of salt. Concentration of salt is equal to M1V1 minus M2V2 by V1 plus V2. So it is equal to M1V1 is how much? 100 into 0.1, that is 10. 100 into 0.2, that is 20. So 20 should take M1, you should take it as M1. Sorry, this is V1 and this should be M1 because this is greater, and this should be V2 and this is M2. Then only you'll get correct answer. So whichever number of milliequivalents, if base number of milliequivalents of base is greater, then we have to take M1V1 as base and M2V2 as acid. So straight away I'm taking here. So 0.2 into 100 minus 0.1 into 100 by 200. So 0.2 into 100 is how much? 20 minus 10 divided by 200. So it is equal to 10 divided by 200, which is equal to 10 divided by 200 is equal to how much? It is 0.10 divided by 200, 1 by 20. 1 by divided by 20, it is equal to 0.05. 0.05. So this is concentration of salt. Now we can apply the formula. First, since this is basic buffer solution, since it is basic buffer solution, so POH is equal to PKB plus log of concentration of salt by concentration of base. So here we can write POH is equal to pKb value for this 1.10 to power minus 5 is, so pKb is equal to how much? It is equal to 4.74 because already the same value we are doing it. So straight away right here 4.74 plus log of 0.05, that is salt concentration, by base concentration is 0.2. So 0.05 by 0.2 is equal to how much? That is equal to 0.05 divided by 0.05 divided by 0.2 is equal to 0.25. So this is, by this you can write POH is equal to, from this you can do calculation, 100% you'll get POH. After getting POH, we'll get pH is equal to 14 minus POH. So you'll definitely get the answer. So please do accordingly. This is the question and this is the answer. There itself, if you are doing it, it will be easy for you to understand. That's why I have tried to complete the problem here. So 0.05 divided by 0.02 is equal to 0.25. So log 0.25 is negative. So pH is equal to 14 minus 4.74. So 14 minus 4.74 is equal to, final answer you'll get 14 minus 4.74. 14 minus 4.74 is equal to 9.26. So final answer you'll get it as 9.26. Because log 0.25 can be neglected because log 1 itself is 0. So it is getting log 0.25 because it's how many times it is going? 0.25 times. So log 0.25 is neglected. So 14 minus POH is equal to 4.74. So 14 minus 4.74, it is equal to 9.26. So we have completed the numerical also. So answer, let us check the answer now. It is equal to 9.26. As I told you, it's equal to 9.26. Then I'll rub it so that you can understand. So it is equal to how much? 9.26. And for this, POH is equal to. So 9.26 is the answer. I hope it is clear. Next we'll discuss. Next question. So next what we have, we have new topic called, here it is missed out. So next we have buffer capacity. What is this called? Buffer capacity. What is buffer capacity? Now we are going to discuss. So please note it down. The number of moles of acid or base. The number of moles of acid or base added, or base only, it is not bases, added to 1 liter of a buffer solution, to 1 liter. 1 liter is important. 1 liter of a buffer solution. 1 liter of buffer solution to change its pH value by 1 unit. To change in its pH value by 1 unit is called buffer capacity. So buffer capacity is noted with letter sign like this. So buffer capacity psi is equal to number of moles of acid or base added, number of moles of acid or base added by change in pH. Change in pH. So what is buffer capacity? The number of moles of acid or bases that must be added to 1 liter of a buffer solution to change in its pH value by 1 unit is called buffer capacity. So buffer capacity is equal to number of moles of acid or base added to the buffer solution by to a liter of solution by change in volume, by change in pH, sorry, change in pH value. Like this is called buffer capacity. This is called what? Buffer capacity. Now let us do one numerical based on buffer capacity. So please copy down. This is not there in the slides. The number of moles of acid or base that must be added to 1 liter of a solution. 1 liter of a what solution? Buffer solution. Whether it can be acidic buffer or basic buffer. So that to change in its pH value by 1 unit. To change in its pH value by 1 unit is called buffer capacity. So buffer capacity is called number of moles of acid or base added by change in pH. Very, very important. I hope you have noticed it and noted it in your classwork. Now let us see one question based on buffer capacity. Problem on buffer capacity. So let us notice one numerical on buffer capacity is simple. When 0.2 moles, when 0.2 moles of an acid is added to 1 liter of a buffer solution, to 1 liter of a buffer solution, the pH of buffer, the pH of buffer decreases by 0.5. What is the buffer capacity of the solution? What is the buffer capacity? What is the buffer capacity of the solution? Is basic model, basic numerical. So straight away I'll do the solution with blue. Solution for this, simple it is. Buffer capacity is equal to number of moles of acid or base added, number of moles of acid or base added by change in pH. Change in pH of buffer solution. So it is equal to number of moles of acid is here how much? It is 0.2. So 0.2 by 0.5, which is equal to 0.2 divided by 0.5. You can guess the answer. It is equal to 0.4. 0.2 divided by 0.5 is equal to 0.4. So our buffer capacity is 0.4. Suppose if they are given, instead of giving 1 liter, if they are given 2 liters, so 0.4 by 2. Suppose if they are given 2 liters, if they have given 2 liters, then buffer capacity is equal to 0.4 by 2, that is equal to 0.2. 0.4 by 2 we have to take, not 1. We have to take 0.4 by 2 divided by 2 is equal to 0.2. Very, very important. So depending on, because buffer capacity is only 1 liter. Definition itself, it shows 1 liter. Since they are given 1 liter, straight away I have taken 0.4. Suppose if they are given the examination 0.2 liters, then if they are given 2 liters, if they have given 2 liters in volume, then 0.4 by 2. Whatever the final answer, divide by that volume. So here volume is 1 liter, so 0.4 by 1 is equal to 0.4. Suppose if they are given 2 liters, 0.4 by 2, it is equal to 0.2. Suppose if they are given 5 liters, 0.4 by 5. So like that depends upon the volume. So in this way, you'll get buffer capacity, and this is called buffer capacity. I hope it is clear. Next continuation. So what are the important points in buffer solutions we are going to discuss now? So what we have done in this session, buffer solutions, to find pH of buffer solution, pH of buffer solution, pH of buffer solution by Henderson equation, Henderson equation, point number 1. And second point we have done, what is buffer capacity? Buffer capacity, and more about numericals on buffer solutions and buffer capacity. We have done numericals also from this. So all the 3 types of numericals are most important. I have given 4 important models. So all the 4 models are important. So based on that models, you can do any problem easily, because those are the best models we have done. So again, now questions based on buffer capacity in the buffer solutions. So next we have what we have done. So these 2 we have done, and numericals based on it, numericals based on, and we have done some numericals also. Now let us see some more questions based on buffer solutions. Basic level questions. This is tough end questions we have done. Now we'll do some basic level questions based on buffer solutions. So please note it down. What is acidic buffer? What is basic buffer? You have to remember. Now questions based on buffer solutions. MCQs for competitive exams. Let us start now. So please note down. One liter of a buffer solution. Just basic level questions I'm giving. 1 liter of a buffer solution contains 0.01 molarity ammonium chloride, which is called salt, and 0.1 molarity is ammonium hydroxide, and 0.1 molarity ammonium hydroxide. The pH, the pKb of base is 5. The pKb of base is 5, directly they are given. Then calculate pH. pH of the solution is pH of the solution is option A is equal to 9, option B is equal to 10, option C, like these questions you'll get expected for NEET, is equal to 4, and option D it is equal to 6. So this is a straight question. I'm doing solution for this. So please note it down. What is the question there again? 1 liter of a buffer solution contains 0.01 molarity NH4Cl. This is called salt, and 0.1 molarity NH4OH. This is called base. So they are given concentration of salt and concentration of base directly. And they are given pKb of base also. It is equal to 5. Now pH. So first, for basic, since it is a basic buffer solution, we have to calculate pOH. pOH is equal to pKb plus log of concentration of salt by concentration of base. So it is equal to pKb value is given how much? 5 plus log of concentration of salt. Salt is given how much? 0.01 divided by base is 0.1. So it is equal to that is equal to 5 plus log of 0.1 by 0.01 by 0.1. This can be taken as 0.1, 0.01 divided by 0.1 is equal to 0.1. Once again, do 0.01 divided by 0.1, which is equal to 0.1. So it is equal to 0.1. That is nothing but, sorry, here I'll write log 0.1. Log 0.1 is equal to 5 plus log 10 to the power of minus 1. So this should be 5 minus 1 is equal to 4, because log 10 to the power of minus 1 is minus 1 log 10, minus 1 log 10. So it is equal to 1. So 5 minus 1, it is equal to 4. So answer is what? Third option. So like these simple questions you will get from for NEET level as well as board, JEE mains level. So in this way you have to calculate. So here question and answer is clear in the same page. So it's better for you to understand. So like that's why I'm doing these questions. Second question. Next question. So please copy down this question. 1 liter of a buffer solution contains 0.01 molarity NH4Cl and 0.1 molarity NH4OH. The pKb of base is 5 and pH of the solution is. Now let us see second question. Question number 2. The pH of buffer solution. The pH of buffer solution prepared by mixing the pH of buffer solution prepared by mixing 50 ml of, again here they have given volume, 50 ml of 0.2 molarity acetic acid and 25 ml of 0.25 ml of they have not given concentration of acetate, that is 25 ml of sodium acetate. Sodium acetate is 4.8. What is the concentration of acetate ion? What is the concentration of sodium acetate given pKa is equal to 4.8. pKa of acetic acid is equal to 4.8. Option, now options. Option A, they have given 0.2. Option B, 0.4. Option C, 0.5. And option D, 0.8. So they are given molarities, molarity, and molarity. Now let us see the solution. They have given what? They have missed out concentration of salt, that is sodium acetate. So pH is equal to, since we know pH is equal to pKa plus log of, that is what? Molarity of salt into volume of salt by, volume of salt, yes, we have to write here. So if they have added volume, you have to consider volume also. So molarity of salt by volume of salt by molarity of acid by volume into volume of acid. Simple, this is like this only you have to take. So then it is nothing but pH is given how much? pH is given 4.8 is equal to pK is 4.8. pK value also given 4.8 and pH is also given 4.8. So 4.8 plus log of molarity of salt is given. We have to find, that is X, into volume of salt is given 25 ml by molarity of acid is given 0.2 into volume of acid is given 50. So substitute this and find out the value of X. So 25 ones are 25 twos are. So 0.2 into 2 is 0.4. So by this you can say 4.8 if you bring this side. So this becomes 4.8 minus 4.8 is equal to log of X by 0.4, because 0.2 is log X by 4. So implies log X minus log 0.4 is equal to log of 0.4 is equal to 0, because 4.8 minus 4.8 is 0. So log X is equal to log 0.4. Log X is equal to log 0.4. So by this implies X is equal to 0.4, because X and X here. So answer is second option. So like these questions are very, very important in buffer solutions. Please do it. So copy down the solution. I'll give time. The pH of buffer solution prepared by mixing 50 ml of 0.2 molarity acetic acid and 25 ml of sodium acetate. They have mixed out here concentration of sodium acetate. That's what they're asking. What is the concentration of sodium acetate? And pH is given 4.8. They have given pH of the total buffer solution is given as 4.8. And also they have given pK value also given for acetic acid is 4.8. So pH is equal to pK plus log of concentration of molarity of salt into volume of salt by molarity of acid into volume of acid. Molarity of salt we are not, we have to find out, that is taken as X, and volume of salt is given as 25 because 25 ml of sodium acetate by molarity of acid, that is 0.2 is given. So 0.2 into volume of salt, that is volume of acid is given as 50. So it is 1 by 2. So X by 0.2 into 1 or 2, that is log X by 0.4 is equal to, bring this 4.8 to this side. So 4.8 minus 4.8 is equal to log of X by 0.4. So by this, since log of A by B is equal to log A minus log B, so it is in the form of log A by B. So by this you can say log X minus log 0.4 is equal to 0. So log X by log minus log 0.4 is equal to 0 means log X is equal to log 0.4, bringing this log 0.4 that side. So X is equal to 0.4 molarity. So this type of numericals I have done in the slides also. Maybe you will not understand in that slides. That's why I have done it clearly again by taking separate values. So please follow this. This is about buffer capacity and buffer solutions. Very important. I hope it is clear. So in the next session, we are going to discuss new topic in this chapter. So work out buffer solutions also. Very, very important. With this, I'm ending this session. Thank you. So please follow what we are going to discuss in the sessions and do more numericals based on buffer capacity and buffer solutions. At the last end of the chapter, some more questions of buffer solutions we'll do of level 1, level 2, and level 3. Since in the lectures, we have done all the tough problems. So you please follow that. Thank you all.